Grignard reaction with benzophenone. Using smooth paper or a small beaker, weigh about 0.5 grams of magnesium turnings and place them in the 100 ml round bottom flask. Using a pre-weighed 10 ml graduated cylinder, measure approximately 2.1 mLs of bromobenzene and reweigh the cylinder to determine the exact mass of the bromobenzene. Transfer the bromobenzene to a stoppered 50 ml Erlenmeyer flask. Without cleaning the graduated cylinder, measure a 10 ml portion of anhydrous ether and transfer it to the same 50 ml Erlenmeyer flask containing the bromobenzene. Mix the solution and then, using a dry disposable Pasteur pipette, transfer about half of it into the round bottom flask containing the magnesium turnings. Add the remainder of the solution to the 125 ml separatory funnel. Then add an additional 7.0 mLs of anhydrous ether to the bromobenzene solution in the separatory funnel. At this point, make sure all the joints are sealed and that the drying tubes are in place. Position the apparatus just above the hot plate and stir the mixture gently to avoid throwing the magnesium out of the solution and onto the sides of the flask. You should begin to notice the evolution of bubbles from the surface of the metal, which signals that the reaction is starting. It will probably be necessary to heat the mixture using your hot plate to start the reaction. The hot plate should be adjusted to its lowest setting. Because ether has a low boiling point, roughly 35 degrees Celsius, it should be sufficient to heat the reaction by placing the round bottom flask just above the hot plate. Once the ether is boiling, check to see if the bubbling action continues after the apparatus is lifted above the hot plate. If the reaction continues to bubble without heating, the magnesium is reacting. You may have to repeat the heating several times to successfully start the reaction. After you have made several tries at heating, the reaction should start, but if you are still experiencing difficulty, proceed to the next paragraph. While the phenyl magnesium bromide solution is being heated and stirred under reflux, make a solution of 2.4 grams benzophenone in 9.0 mLs of anhydrous ether in a 50 ml Erlenmeyer flask. Stopper the flask until the reflux period is over. When the reaction has started, you should observe the formation of a brownish-gray cloudy solution. Add the remaining solution of bromobenzene slowly over a period of 5 minutes at a rate that keeps the solution boiling gently. If the boiling stops, and add more bromobenzene. It may be necessary to heat the mixture occasionally with the hot plate during the addition. If the reaction becomes too vigorous, slow the addition of the bromobenzene solution and raise the apparatus higher above the hot plate. Ideally, the mixture will boil without the application of external heat. It is important that you heat the mixture if the reflux slows or stops. As the reaction proceeds, you should observe the gradual disintegration of the magnesium metal. When all the bromobenzene has been added, place an additional 1.0 ml of anhydrous ether in the separatory funnel to rinse it and add it to the reaction mixture. Remove the separatory funnel after making this addition and replace it with a stopper. Heat the solution under gentle reflux until most of the remaining magnesium dissolves. Don't worry about a few small pieces. This should require about 15 minutes. Note the level of the solution in the flask. You should add additional anhydrous ether to replace any that is lost during the reflux period. During this reflux period, you can prepare any solutions needed for experiment 36A or experiment 36B. When the reflux is complete, allow the mixture to cool to room temperature. As your instructor designates, go to either experiment 36A or 36B. Once the Grignard reagent is cooled to room temperature, attach the separatory funnel and transfer the benzylphenone solution into it. Add this solution as rapidly as possible to the stirred Grignard reagent, but at such a rate that the solution does not reflux too vigorously. Rinse the Erlenmeyer flask that contained the benzophenone solution with about 5.0 ml of anhydrous ether and add it to the mixture. Once the solution turns a rose color and then gradually solidifies as the adduct is formed. When magnetic stirring is no longer effective, stir the mixture with a spatula, remove the reaction flask from the apparatus and stopper it. Occasionally, stir the contents of the flask. The adduct should be fully formed after about 15 minutes. Add enough 6 molar hydrochloric acid, dropwise at first, to neutralize the reaction mixture, approximately 7.0 ml. Enough acid has been added when the lower aqueous layer turns blue litmus paper red. The acid converts the adduct to triphenylmethanol and inorganic compounds, MgX2. Eventually, you should obtain two distinct phases. The upper ether layer will contain triphenylmethanol. The lower aqueous hydrochloric acid layer will contain the inorganic compounds. Use a spatula to break up the solid during the addition of hydrochloric acid. Swirl the flask occasionally to assure thorough mixing. Because the neutralization procedure involves heat, some ether will be lost due to evaporation. You should add enough ether to maintain a 5 to 10 ml volume in the upper organic phase. Make sure that you have two distinct liquid phases before proceeding to separate the layers. More ether or hydrochloric acid may be added, if necessary, to dissolve any remaining solid. Transfer your mixture to a 125 ml separatory funnel, but avoid transferring the spin bar. Shake and vent the mixture and then allow the layers to separate. If any unreacted magnesium metal is present, you will observe bubbles of hydrogen being formed. You may remove the aqueous layer even though the magnesium is still producing hydrogen. Drain off the lower aqueous phase and place it in a beaker for storage. Next, save the upper ether layer in an Erlenmeyer flask. It contains the triphenylmethanol product. Re-extract the saved aqueous phase with 5.0 ml of ether. Remove the lower aqueous phase and discard it. Combine the remaining ether phase with the first ether extract. Transfer the combined ether layers to a dry Erlenmeyer flask and add about 1.0 grams of granular anhydrous magnesium sulfate to dry the solution. Add more drying agent if necessary.